Hello, everyone. We'll start in a couple of minutes, just waiting for more people to join in. So, thank you for being here on time. We'll take a couple more minutes and we'll start. All right, time to go. I'm always the one that's blamed. I'm always the one that tries to be on time, but I'm the one that waits. So I know how everybody here feels. So let's not drag this any further. Thanks everyone for who joined in already. I hope more will join in a few more minutes, but let's get started. So again, thank you for joining. We're going to talk about simple hacks for cost optimization with Karpenter. I'm not sure what the mix of audience here. This is a slightly different talk was given during last reInvent by our CTO. I gave kind of the same talk during last AWS Summit in London. And this is a revised version I think that's the best version because it's going to be laid out in an easier to understand template and you're all sitting in front of your screen, so easier to digest. So let's back up a little. My name is Omer. I'm an infrastructure architect at Zesty. You might also know me from YouTube. If you don't, email me later. I'll send you the link. And while I cannot see you, it's very nice to meet everyone. And let's get started. So let's talk about the goal here first. There's a triangle of stuff we usually try to achieve with infrastructure. And we're trying to find the sweet spot for applications to run efficiently. It says so on the left, for apps to run efficiently and fast with minimal ops hassle, right? We want everything to work. We want it to be working well, obviously. And we want to lower the cost because if you just throw money at everything, then there's no complexity or performance, right? You can pay as many engineers as you like. You can scale for basically infinity, and then there's no problem, right? Performance is solved. The same goes if you try to reduce complexity, then you have other problems. So we're trying to find the balance for things to be performant, not as complex, but also cost efficient in a way that can, hopefully be self-healing. It's kind of a big term, and I always hated to hear that. But for real, a system that's self-healing and automates most of its process. I'll get to what I mean by that, but automate, scaling up, scaling down. What can I scale? How can I scale? Whether it's going to run, spot instances, on-demand instances, GPUs, stuff like that. So let's get into it. First off, this is before showing this slide in London. This is harder here. You can try. There's a raise your hand in the chat. And by the way, if you want to ask questions, there's a Q&A button on the bottom. So I asked people to raise their hand if they've ever heard about PDBs in Kubernetes. So if you guys have heard of it, you can try and raise your hand. Cool, that's nice. So PDBs are pod disruption budgets. It's something in Kubernetes that you can use to configure disruption in your cluster. And then I went ahead and asked, okay, how many of you actually know about disruption budgets in Karpenter? And out of probably 50 or 60 people, I had one show of hand. So most people are unaware of that. And you can configure Karpenter to behave in a similar manner because Karpenter, at the end of the day, when we talk about specifically consolidation, which is, you know what, let me back up a little. Consolidation in Karpenter, for those who are unaware, is your way to reduce the use of nodes. right? You're basically configuring a policy. So in this instance, it's when empty or underutilized. So you're telling the system when you see a node that is either completely empty, no pods are running there, or is very much underutilized, it's one pod in a huge instance, you can consolidate it. Consolidation means gracefully remove that pod away, schedule it on another pod, on another node, sorry, and then you can remove that node from the system to reduce the costs. So that's consolidation. But as you can imagine, this is a disruptive process, not a huge one, but we're killing a pod, we're making it restart. So that's a process. We're removing a node, so creating kind of a stress in the system. There's stuff moving and going on. So when you configure disruption, while most people end by saying a consolidation policy, and this is the most the one that you see always when empty or underutilized, you can tell it how long or how many minutes to wait basically after the node is completely empty. So for example, 5 minutes, but you can also add a budget. So this would mean if you're disrupting, don't disrupt more than 10%, for example, of nodes. And you can add another one and say schedule. So this, I think the cron here says something like Monday to Friday, something to 5, I forgot what it is, but basically Monday to Friday from 9 a.m., I think. For a duration of 8 hours, do not disrupt anything, as in 0 nodes can be removed from the system. If you combine all of these, you get both a system that can consolidate your nodes, but do it, you remember from the triangle we had performance, so this goes into performance. This is keeping production healthy during working hours in this instance. Maybe your hours are different, maybe it's during the night or the weekends. Whatever it is, you can configure a schedule where you don't want disruption or you want a slightly less disruption as opposed to quote unquote dead hours where you can disrupt much more. So these are disruption policies, disruption budgets rather, in disruption policies within Karpenter. The next bit that can help you a lot is diversification. To some, this may seem or sound very straightforward and very simple, but we see so many customers that are either ignoring this bit or doing it completely wrong. And I'll explain. Your system can probably handle more than one type of instance, but most production systems we see are very, very much fine-grained to a very specific type of node. It may be a C5 dot extra large, something like that. There's a good reason to do that because you want your pods to run on the best architecture possible. But in times of stress, you may want to remember that at the end of the day, while it seems like scale is an infinite term when it comes to AWS or any type of cloud, that's not always the truth, especially if you run in smaller regions, especially if you run in smaller availability zones inside these regions, and if you run in peak times, Black Friday, Cyber Monday, things like that, when lots of huge companies are trying to get as many resources as they can, compute resources, these may be stressful times. So if you have all of these combined, you may end up, getting with no availability if you need to scale during those times. So if you create some diversification, for example, in the instance category, maybe you can go, your M5 large is very much the thing you still want to keep, but add some C instances, R instances. It may be, R instances are always viewed as these memory intense, huge beasts that are very expensive, and they are. But if this saves production, you may want to consider keeping that inside. Same goes to instance generation. It's okay to drop a generation or two. Again, it might not be the best resource. It might be a little bit more expensive, the way that Amazon tends to go with pricing. But again, if that saves production, it's worth counting in. And something that might be more prevalent, I'd say, is adding those spot instances. So you can add a mixture of spot and on demand. Let Karpenter, you either prioritize one or the other, but always keep a bunch of the other group. For example, if you're used to run on demand, that's great, but maybe use some spot instances to, cover some of the workload. Or on the other hand, if you're already, and that's usually not the case, but if you run a bunch of spot instances, keep in the mix a little bit of on-demand instances to make sure that, again, during those peak times, everybody's going to be seeking those spot instances. So they may be taken away from you. You have the 2-minute gap time where you get a notification and then the instance is taken. It's going to be much more common during these times. So this is diversification. The other point is avoiding extremes. You can basically go to Karpenter and tell it, here's a policy. for limitation for a node pool. Now it's going to be very high values, but maybe we have one node pool that can, the scale is in a crazy amount of resources. I don't know why. I can think of use cases, but it scales like crazy. That's the ADI because you let it, which is good, right? Something's going on. The system is dynamic. You apply consolidation. It's elastic, right? It's the word we like to use. It can expand and shrink, but at some point it gets either too expensive or can just spiral out of control. I don't know why. Memory leaks or a bug in the system that uses way more CPU than it should. You want to set some caps. You can think of it like limits when you give your pods a limit of CPU and memory. You can do the same with Karpenter. You can tell a node pool it can only run up to, for example, 1,000 CPUs, 1,000 gigs of memory, maybe two. Not a great number to compare here, but maybe only 2 GPUs. So even if you have 1,000 pods waiting for each requiring one NVIDIA GPU, it's not going to work because you have this capacity limit, at least not with Karpenter. So it's something to remember. Karpenter is great at responding fast. You want to set your capacities always. And the next bit, you know what? I touched this. I'll show you that in another slide. It'll be a little bit more interesting. So we'll skip that. Okay, there it is. I talk a lot of time with our customers. I see a question. I'll get to that in a second, by the way. Just don't think I don't see that. I speak to customers and then they say, yes, we have bin packing applied with Karpenter consolidation. That is not correct. It doesn't go to say that it's completely detached from reality. There is some commonalities, but bin packing is not something accessible to most. And I'll get to why in a second. What you see here in the configuration on the right is a kube scheduler configuration. If you're using EKS, if you're using GKE, if you're using AKS on Azure, you cannot access the scheduler for a myriad of reasons. I don't know why. The cloud platforms as of today do not let you configure the scheduler. I think Google lets you kind of play around with some of the configurations, but basically you don't have control. So bin packing is before you even schedule anything, you can tell the system, please use in this instance the most allocated node. For example, if I have a bunch of pods trying to run, instead of distributing them as much as I can, I would like to bin pack them to be more efficient with the resources I have in place. Consolidation kind of does the same, but backwards, right? We've already distributed everything. Now when something is underutilized, we'll kill that pod and then the node. So we'll end up kind of with bin packing, quote unquote, but we've done it the other way, which is much more disruptive. We first distributed things and then we've done it. There is a solution to that. I don't want to get too deep. You can run your own scheduler in parallel. That would mean adding webhooks and stuff. We are doing it personally. We are doing it in our production clusters for a very specific use case and a very good reason. You may not want to go down that road, but it's important to keep in mind that consolidation is not bin packing. Now I'll stop for a second and look at the question. Okay, I don't want to stop everyone, so I'll keep that and I'll try to come back at the end. Let's move on to the next slide. If you have more answers, more questions, sorry, feel free to shoot them in the Q&A. Right, so the last bit of diversification is considering daemon sets. Now, daemon sets are the silent killers of Kubernetes. And the reason is, look at the small, and it's a very small list to the right. That's not even, we've seen double that amount. These are very common daemon sets that would start on any type of node, regardless of whether you're running R8, 8 extra large, or a T2 micro. You're going to set an AWS node if you're running on EKS because you need, control of the node through EKS. You must have kubectl. If you're running core DNS, you'd need that. If you're running the CSI for ABS, you'd need that. EFS, same. CloudWatch Agent, FluentBeat, Datadog, stuff that probably some or most or all of you are using a mix, some kind of a mix of these. And these accumulate. Right? And then again, every time you start a new node, this capacity is gone. And we're talking here like a gig or two of, probably around that of memory. And look at how much CPU is used. This is something to consider. There's two ways you can go about that. First of all, not launch as many daemon sets. And the other is making sure you only have the relevant daemon sets on the relevant pods. For example, if I'm using EBSs And EFSs, I'm probably not mounting one EFS to, all of the nodes, all of the pods in the system. I can be smart about it. Same goes for EBS. Probably the same goes for Datadog. Not sure, depending on your use case, but just keep that in mind. This is a more visual drawing of what I just said. So when these are applications, if you have app 1, app 2, app 3, and app 4, you can distribute them between instances. Once these are all daemon sets, the same group of the same pods go on every single node that starts, regardless of its size. So that's something to remember. And again, I might be saying something that's very straightforward for some of you, but you won't believe how many companies just ignore that, right? And they add more and more. This is a quote from the AWS docs. AWS Graviton-based instances cost up to 20% less than comparable x86 Amazon EC2 instances. I will repeat that. If you're going to use Graviton, on average, you can save 20% of your bill. Now, why do companies don't just jump on that opportunity and go ahead and use Graviton across the board? There's a good reason, and we'll talk about that. So just remember, Graviton is a kind of a life hack. You get everything, like everything's better. The pricing, the resources, you just get a great opportunity across the board, but it makes you do an extra step. The extra step would be, and it says here on the last point, the third point, utilized ECR multi-arch build capability. If you know it, you know it. If you don't, it sounds way more complicated than what it actually is. This would mean that, let me go back a little. When you build an image out of the box, it builds based on the architecture that the CI runner is using. So if it's x86, it just pushes an x86 based image to ECR or whatever registry you're using. If you've ever used an Apple Silicon Mac and tried to pull an 86 image and then start running it, you've probably seen that small warning that says it wasn't built for that architecture. It might work, it might not work properly. So you know about that. There's a very easy solution. Now, let's talk about the mistakes that companies do often. They would use dual tags and they would build, my image colon x86, my image colon ARM Graviton, right? And then they'll add versions. So each one gets like a matrix of different architectures and different versions. There's no reason to do that. If you're already using Docker, you get BuildX. And BuildX is a way for you to cross-build images for different kind of platforms. For example, Docker BuildX build _platform, and you can say both Linux AMD 64 and ARM 64. Then you add your registry with the tag registry app, and the tag is just your version, your commit hash, whatever that may be. It does not need to be the architecture, has no relevancy to the tag. -- push will actually finish that by building and pushing to the remote registry. Once you've done that, ECR or whatever other registry that supports, what was the name? Multi-architecture build, right? Multi-arch build capability basically means that the registry knows how to hold a policy in place. That policy, when you push it's the same image, but different architectures, would know to serve them depending on where you come from. Okay. So ECR currently holds our app, latest, but one is built for ARM and one is built for AMD 64. When we use the node and we run Docker pull, we're not actually running Docker pull. That would be Kubelet that does this for us. But Kubelet would run Docker pull app latest. If it's coming from an ARM node, it'll just pull the right image. If it's coming from an x86 node, it just pull the right image. And there's nothing for you to do. You just run one build command during CI, which does both or more than two, pushes them to your remote ECR, and your node can keep working, and you can use multiple architectures. You're not even locked to one. So that's another hack to remember. Again, something that sometimes when I talk about it, it sounds, to some people, this would mean like, this guy doesn't know what he's talking about. That's, of course, like straightforward, right? To others, they're just unaware. It's not about being smart or not being smart. It's just awareness to small stuff that you can do. The next bit is cross-AZ traffic. And again, this comes up a lot. When people think about not the complexity, but rather the expensive aspect of running cross-region traffic. This when usually people think about, or companies rather, think about running multi-region architecture or multi-region clouds or multi-cloud, they would immediately associate that with cross-region traffic, which is very expensive for a great reason. It is very expensive. But when they decide, okay, we're not going to go cross-region because it's super expensive, we might separate parts of the architecture. We might create what you call a pilot light. There's a lot of ways and approaches to go about that. But they do create the separation. But then inside their region, maybe you assist one, they'll use 5 or 6 different availability zones, whatever the region offers. But the cross AD traffic might be just as crazy. It might be not as expensive, but it very much is expensive compared to just running internally in the availability zone. Now, I'm not saying run everything in the same availability zone. We've all seen UAssist 1, whatever it was, just burning in flames. You can use 2. You can use 3. Don't use the entire array unless you have a very good reason. And you can be smart about that as well. If you have, I don't know, an array of databases and backend systems that use these, you can be smart about that and try to place them in 2 different availability zones or in the same availability zone to be, close in proximity. That gives you both lower latency and better cost efficiency. So prioritizing placement in a specific AZ, this is a configuration for Karpenter that helps you do that, the topology at Kubernetes/zone, and you can just dictate what zones it's going into. Fun fact, which again, I don't know if you know or not, the A at the end is different between companies. If I'm saying UAssist West 2, but A, it's not the same A as you or the third guy. AWS are kind of mixing them around us so that we cannot, I think it's about not being able to align with someone else because I guess obvious reasons. So that's it. Be mindful of resilience, right? You do want to create some distribution, but also think about the costs. All right. I don't usually get to that in this talk, but I think it's important to touch about spot instances again. Let's go through the list and then I'll get into my thought specifically, and feel free to add questions if you have them. So the first thing you want to think about is configuring fallback to on-demand. I think that's fairly obvious, right? If you're running your architecture and prioritizing spot instances, again, for a good reason, you do want to keep some on-demand instances in the back, so you can do that. Alternatively, you want to create a weighted node affinity. So you can basically, I don't want to go, again, too deep into something that's very technical, but you can create different weights for node affinity and decide what goes where. Again, in weights, the number of resources allocated per node. And then you want to make sure that you're able to handle interruptions, because when you run on spot instances, by definition, your application is going, your process is going to die. This means either no sticky sessions, graceful shutdown, as mean knowing how to handle different signals, sig kill. It's thinking about retry for requests, aggregating requests, HTTP requests can just evaporate. You might want to think about a message bus or a queue in between. So there's lots of architecture decisions to think about that when you're going for resilience. This gives you, again, a way more resilient system that can handle everything, including processes dying left and right. Sometimes it happens a lot. When you use spot instances, it's part of the game. By definition, that's what's going to happen. And I think that's expected. With Kubernetes, it's a dynamic system. It was built for it. So if your infrastructure and your system and your architecture is built around that, it's easier to work with spot instances. Another something to consider is that 2-minute notification. The 2-minute notification is important because sometimes you'll see, let's talk about the extreme case of pods. Like you probably know hot start and cold start. So let's go to a freezing start, right? Which would mean I now need the new pod to start, but I don't have capacity of nodes. So we need to start a new node. This node has to do a bunch of things. It has to, first we need to speak to the cloud provider to start an EC2. Whatever you've set in the init script, that's going to run. When that's ready, we have a new node. Now we have to pull an image. If the image is large, it's going to take a few seconds, right? Hopefully not minutes. You pull the image. Now you have a compressed file, which you need to unpack to layers. So there's an unpacking going on, and that can take a long while. Then when you're done with that, you need to start the process. Now, if you're used to, JVM-based languages, that might take a little bit longer than expected. Maybe seconds, maybe long seconds, 30 seconds in some extreme times. So all of that process might take a very long time. If it takes what I've described can take way more than 2 minutes in some extreme cases. If it takes more than 2 minutes to start a process, there's no point running that unspot instance, right? Uh, Things to think about, which is a lot, right? What you set in the node, the scripts that started, how big your images are, where are you downloading them from, unpacking. There's many ways to play with unpacking different layers, improving that, being more, smart about how you pack images and more. Not for this talk, just something to consider. Yeah, you want to monitor the fallbacks, making sure that everything's fine. That's obvious. And then combine with consolidation, because again, if you have way too many instances, you probably want to consolidate them using Karpenter. I think that's enough. The last point that I want to get to is what's left, as in bridging. We still have some gaps in the system. And I'll get to the questions in the Q&A, don't worry. So we as a company, we're looking at all these stuff, and these are all things that are like not only seen in the wild, but implemented in-house. And that's why we give that talk so many times. But we've built something that we call the fast scaler. Again, I mentioned the bit where it takes the extreme cold start, right? The freezing start from cold node all the way to a running process. Depending on the size of the image, and there's a table here that shows you what's happening from 5 gigs of an image, and we've seen way larger than that, all the way down to 100 megabytes. So it does not all that matter if you have a very small image, but we've built a way for you to get sometimes 8 times faster response. And I'm talking from completely dead or completely cold start all the way to a running process. The way we do that in a nutshell is we keep a bunch of EC2s hibernated on the side. They're pre-cached with your images. And then when we need an instance, both Karpenter and our system will be triggered. We'll do it alongside each other. But whoever comes first, first come, first serve in Kubernetes. That's how the scheduler works. It sees a new instance that started from a hibernated node. It serves way quicker. So 36 seconds instead of, over 2 minutes makes a huge of a difference. That would mean an application that up until they could not run on spot instances can now enjoy that. And naturally, as the images are smaller and more efficient in how they're built, it's not as effective. But again, it might be for some companies, it is life-changing in the way they can handle their infrastructure. And the end of it is that we as a company try to wrap everything around, I'll say, attention between stability and cost efficiency. So what I've just described gives you spike protection, right? Because now that you know that you have instances that can start in a matter of 15 to 20 seconds, you have a live process up. This doesn't only mean you're being more efficient. It means that now if there's a spike in the system, again, Black Friday, tons of requests, you can now handle things so quick. You don't need to keep as big of a buffer. Now, here's another fun fact. I sometimes ask when I'm on stage, how efficient do you think most companies, on average, how efficient they are with the system? Meaning, what's their utilization percent, right? How much of the if they have, 10 instances, how much of the CPU resources on that system is utilized? It's not only CPU, it's a mixture of CPU and memory. How much is in use? On average, and then I can back this up with data. I think it was Puppet Labs who have done the research. It's 6%, meaning 94% on average of some Kubernetes, most Kubernetes clusters in the world is underutilized. Now, I'm not saying you should be 94% efficient. That makes no sense. Usually the rule of thumb is keeping 30% buffer. That's usually. So if you're above 50%, you're doing a great job. The average is 6%, which is nuts. So this would be the spike protection. We have 2 more layers, one on top that handles your right sizing, meaning everything that's around setting the pods, requests for CPU, for memory, for GPUs. All of these are being changed for you on the fly dynamically based on usage. And underneath that, we have another layer that does this optimization. Once you've optimized everything here, you have a bunch of EC2s running. You probably want to handle your commitments. So there's different terms on different clouds, but on Amazon, it used to be the common way used to be handling reserved instances. Today, it's leaning more towards saving plans and things like that. But having all of these layers in automation brings us to the first triangle, right? Being as efficient as I can with my resources, reducing the cost as much as I can while not going crazy with complexity. That's basically. Now you feel free to ask questions. I'm going to try and address what I'm seeing here. So the first one by Eric. Using Karpenter for months, we're now seeing undesired behavior where Karpenter scales too aggressively and does not properly scaling. It's not related to blocking PDBs. One cluster 6 instead refused to scale. The cluster is optimal, therefore nodes. Switching to cluster autoscaler on the same cluster is a similar behavior. Okay, Karpenter logging, even in debug and analyzing event logs is not explaining why it refused to scale. I'm trying to think. It's honestly, I need to read it quietly later and think about that. So feel free to email me. I have not seen something like that. In my experience, it usually boils down to configuration in Karpenter. Something is missing there. I'm not sure. This is just off the top of my head. I'll think about that. I'll read that quietly later. Is Karpenter an AWS product or it can work with GKE? As far as I'm aware, Karpenter is an open source done by AWS. It's now, there's a port for Azure, so you can work with there as well. Haven't checked in the past couple of months. Pretty sure they're working on a port for GKE. I think not at the moment, right? So basically AWS and Azure. Does Karpenter support percentage-based capacity type distribution with a single node pool? If not, what is the best practice to achieve 80-20? I think not. Pretty sure there is a configuration to capacity between spot and on-demand. I'll have to come back to this. I'm pretty sure there is a way. I just don't remember it live. How does it differ from KEDA? So KEDA helps you configure auto scaling for usually custom metrics, right? So it can be normal stuff like jobs in a queue or something like that. It may be things that are coming out of your application. So the difference, when you say this, I'm not sure, I'm not sure if you're addressing what I mentioned about pod right sizing or about Karpenter. I'm assuming it would be pod right sizing because this is about pods. So KEDA is something that feeds into the HPA and helps it scale based on custom metrics while we adjust it on the fly. So to put simply, KEDA is something that the customer always knows better than me, a service provider. I don't know the context of your application, nor do I want to. While HPA is something that is easier to, let's say, monitor and adjust on the fly because it's just usual metrics, right? Memory, CPU, stuff like that. Okay, we have a memory bounded workloads. Karpenter spins 30 huge instances instead of R instances within total cost list. How can we instruct Karpenter to select the R nodes? I'm not sure I have the full context here, but if I understand correctly, you've created the diversity by saying, okay, I can accept C6 large, but also R6 when this extreme time comes. How do I make it select? So the way it's not really, you're asking how can I instruct Karpenter to select the nodes? I'm not sure you can instruct Karpenter to select these. What you can do is push a bunch of them in the cluster and then let the scheduler know that you want them to be first placed in that pool using affinity rules and weight classes. That's the way to go. I hope I have the full context, but this is basically what it is. If it isn't, feel free to email and we'll get to the bottom of this. Do we have more time, by the way? Where are we at? Yes. Okay. What's the best practice that most people forget when using Karpenter? The best practice that most people forget when using Karpenter. I'd want to say one of these five. Not sure if there's one thing. I'm not sure. Let me think if I can go with one answer. Um, It'll probably be the diversity. I think most companies just set and forget, and they don't realize that their infrastructure is changing over time. Things are dynamic, which is something you want to consider, and they just set something and let it go. And when there's problems, they start thinking about more node pools and affinity rules and things like that. Diego asks, what's the best way to cost optimize pods that have a memory spike during startup, but then settle at maybe 80% less memory than the spike? Memory is always more complicated for a couple of main reasons. First of all, it's not something that on average drops. It's not as easy as CPU. And it's more complicated because it's not compressible. So there's no way to share it among different applications. Um, what's the way to settle it? I'll give you an annoying answer. It very much depends. It depends on the context. I can throw a rule of thumb, but I think with memory, there's no rule of thumbs which are easier for me to go with when we discuss CPU and things like that. So it varies. Sorry, but it depends on the context, very much so. If I'm trying to understand, it's a memory spike, but not a memory leak, because memory leaks are another type of beast, right? Memory leaks are a problem that you want to usually cap and to identify. Good question, though. We're migrating one of our main workloads, 90% of our cluster, to Graviton. Would a weighted ARM node pool with the strict limits make sense as the best way to roll that out? Just scale up the limits on ARM node pool as we progress. Yes, totally. I think that's the way to go. It's kind of like a canary deployment, only applied to nodes. So absolutely, I would even start softer, 50-50, and then gradually over time, yes, move on to ARM. Unless you have again, part of diversity or diversification rather is being able to launch both. But if you're good with ARM and you're not worried about availability, absolutely, it makes sense. Yes, I think that covers not perfect answers, but all of the questions. So if there's anything else, feel free to email. I think I'll ask my panelists here if we have an email in the invitation, so you can use that. I can leave my email here. You know what? Let me put. Oh, I don't have a way to use the quiz. Anyway, you can email us at info@zesty.co, or you have my email, I think, on the invitation, and we'll also send you all a thank you note with an address. But basically, yes, info@zesty.co, forward all the questions there, and we'll make sure they're answered. With that, thank you for joining again. I hope this was valuable. And if you need anything else, again, email us. Thank you.